In this demonstration, I'll show you how to use L'Hopital's rule to find the limit of a function. And specifically what we're asking is, what happens when the limit leads to 0 to the power of 0, or 1 to the power of infinity, or even infinity to the power of 0? And in these cases, L'Hopital's rule applies, as in the previous examples, by bringing one term to the denominator. Let's tackle the first of two questions. Here they're asking us to find the limit as x approaches infinity for x to the power of 1 over x. The technique that you should use here is to set this function as y. So y is equal to x to the power of 1 over x. And the next thing that you want to do is ln both sides. Take the natural log. Ln of y is equal to ln of x to the power of 1 over x. And according to the log rules, when you ln a function with a power, this power travels to the front. So you end up with ln y is equal to 1 over x ln x. And technically what we're supposed to do right now is to take the limit of both sides. So what I'm going to do is write down limit on this side and also a limit here. So if we take the limit as of right now, what happens is you end up with 1 over infinity, which is 0, and ln infinity, which leads to infinity, and this would give you a scenario where you have 0 times infinity. And similarly, if we were to rearrange this like so, ln x over x, we get a situation where you have infinity over infinity. So how do we tackle this? We can use L'Hopital's rule and differentiate the numerator and the denominator, and then once again take the limit after that. So let's do that. The derivative of ln x is equal to 1 over x, and the derivative of x is equal to 1. So if we were to take the limit of 1 over x, we end up with 0. Now if you recall, the left side was ln y. So we can get rid of this ln by setting both the left and the right side as powers to the base e. For example, we had ln y is equal to 0, which is the limit that we took on the left side. And if we raise these to the base e, we end up with y is equal to e to the power of 0, and e to the power of 0 is equal to 1. So therefore, the limit as x approaches infinity for x to the power of 1 over x is equal to 1. Let's proceed to question number 2. In this question, they're asking us to find the limit as x approaches infinity for x to the power of ln 5 over 1 plus 10 times ln x. We can use the same technique as before, where we set this equal to y, and if we do that, we end up with y is equal to x to the power of ln 5 over 1 plus 10 ln x. And we're going to take the ln of both sides, which leads us to ln y is equal to ln 5 over 1 plus 10 ln x ln x. Next, I'm going to rearrange this where we have ln y is equal to ln 5 times ln x over 1 plus 10 ln x. Now, if we were to use L'Hopital's rule, we would end up with the following. At the top, we would get ln 5 over x, and the reason for that is you have to consider this as a constant. That's a number, right? And ln x is equal to 1 over x as its derivative, so the ln 5 would simply go on the top. And on the bottom, the derivative of 1 is equal to 0. And just to signify that we're using L'Hopital's rule, we'll write down an h. And the derivative of 10 times ln x is equal to 10 over x. So I'm going to rearrange now these two quotients, ln 5 times x over 10 times x. The two x's cancel out, and that is the limit of the right side. So essentially what we're left with is ln y is equal to ln 5 over 10. But we still have this problem here. We're going to revert this back into terms with the base e by raising them both to the base e. This gives us y is equal to e to the power of this thing, and that is the limit for question number 2. And this concludes our series on L'Hopital's rule. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at biology-forums.com. We are an online service for students seeking free homework help. See you soon.